All right, the topic, part C, basic concepts and SQL queries. Here, let me, keep my eye closed. So from here, it looks like we only have 60 minutes. 60 minutes. All right, let me just complete the lecture part first. C.1 database concept. In this part, I like to explain some basic database related concepts. All right. What is a database? First, here a simple description for the database. It's a collection of related data. Collection. Related. This word is important because later we will call this type of databases relational database. So here, you can see this word is very important. A collection of related data. We have any special requirements on the data? Definitely we know it cannot be arbitrary data, right? The data must have some business meaning there, right? So it should have business background because the reason we use databases, we want to do our business, okay? We want to develop some real-world applications. And the business data, our business data is stored in these databases. And explore relationships among data. So here, the relationships very important, correlated. So the data is not isolated. So there are a lot of relationships in data, among data. And we need to make sure the relationships reflect the business correctly in the right way. All right. Here we do some abstract discussion. Okay. With some business purpose. Definitely, because when you develop an application in the real world, you should have some specific purpose for your application, right? For example, for our university, they need to use, databases containing, students, instructors, data. Business purpose there. Model aspects of reality. The reality, it's a lot of objects. Later we will have a name, call it entities. Entities, Here, student is an entity. Entity. We will use the name entity. Here you can see one concept we frequently used in our database is entity. Another, relationship. We already mentioned that here, relationship. So two basic concepts we frequently study in our databases: entity and relationship. Student is entity. Instructor, entity. Course is an entity, right? Section. You may have many, different real-world objects. So we, call them entities. Model aspects of reality. Okay. So closely reflect the real-world situation. All right. And here, and but we know our business world keeps changing all the time, right? Yeah. So a lot of things could change when you do your business design, when you do your database design. Yeah. So it is quite normal. The database designers, you need to change your database design frequently. Okay, yeah, that could happen, especially at the early stage of database design. Yeah. So when you start a new application from the scratch, okay, yeah. Because at that time, the early versions of your code, you may have a lot of problems. You may not describe that business world or aspects of the business world, not quite right? Yeah, at the beginning. Yeah, so your understanding of your business, may have a lot of problems. Yeah, so you need to fix your problems. Yeah. So at that time, you may need to change your database design frequently. Yeah. So that means our database description statements should allow us to make the change easily. Okay, so every time if we like to modify, different places, we can do that easily. Yeah. All right. Organized in a special way to support certain operations. The data should be organized in a special way. Yeah. So although the special way, yeah, but you can imagine the way is not unique, right? Yeah. People can use many different ways to organize the data. Okay, yeah. Yeah, but here, although it's not unique, but there is an industry standard used to organize the data. Yeah. All right. So here we use the SQL. Yeah. So the well-known SQL. Yeah. So we will look at that later. Yeah. So here you can see the basic operations, 4 operations: retrieval first, insertion second, yeah, retrieval from existing data, insertion for new data items, yeah, update, yeah, you may modify your data, yeah, and deletion. So these 4 basic standard operations, yeah, when we manipulate our data, yeah, and we use the SQL language, SQL, structured query language. That is the industry standard. Industry standard. All right. So otherwise, you can imagine, yeah, because the data can be organized in so many different ways. If we do not have a standard, so different group of people, they use different ways to organize the data, then it's very hard for us. We as application programmers, how can we handle those so many different ways? Here, the good thing is because this SQL standard, yeah, did a great job. Yeah, so people accept it and make it industry standard. Yeah. So now we only need to learn SQL. Okay, we do not need to learn, other different languages. Yeah. All right. Then let me explain one by one. Retrieval with business properties. When you do the retrieval, yeah, actually, among these 4 basic operations, this retrieval part is the hardest. Yeah. Hardest, that means there are so many different ways to do the retrieval. Yeah. And for this class, we spend most of our SQL query time on this retrieval type. Yeah. Okay. Yeah. So this is the hardest part. Why hardest? Because you need to specify many different business properties when you do retrieval. Okay. When you do retrieval, which part of the data you want to retrieve, and what properties and what relationship you want to have, so many different ways you can specify in your SQL statement. Yeah. All right. The remaining three are much easier. Yeah. Yeah. The remaining three, because, just usually we use the basic way. There are small variations, but basically, yeah. So just the structure from the structure point of view, much easier, and we will not spend a lot of time on the last three operation types. Yeah. All right. Insertion, add new data. Yeah. Update, modify existing data. Yeah. So there are some simple rules. We will go there later. Yeah. Deletion. Yeah. This deletion, this part is different from the first three in a very important part, because for the deletion, think about if you make a deletion operation that is wrong, what would happen? That could be wrong, right? Yeah. Anyone could make some mistake. If it is wrong, think about the data you have deleted may not be recovered. Think about that. If later you realize you make a wrong deletion, that you may cause some big problem, right? Yeah. If you delete it by accident, how to recover it? Right? Yeah. Especially you delete some critical data in your business. Think about that. So that's why when we do the deletion operation, we should be extremely, cautious. Yeah. And here I put two types of deletion. One logical deletion, another physical deletion. Okay? From the name, these two different names, you can understand the difference. Physical deletion, data removed from the hard disk, hard drive permanently. Okay? That means cannot be recovered. All right. Physical deletion. Yeah. Physical storage. It is removed from the physical storage, so it cannot be recovered. Okay. No way to recover it. But logical deletion, yeah, could be recovered. Yeah. This type could be recovered. Logical deletion, actually, we find some logical way to make that piece of data not appear in our database, but the data is still stored on the hard drive, on the hard disk. Okay, if you want to recover it, you just something like you set a special flag to denote that data piece is deleted. If you want to recover it, you just, reset that flag. All right, yeah. So logical way, then you can recover the data. So actually you can protect your critical data for your business. Yeah. So think about that. Yeah. So when you make your database design, that factor should be considered. Okay. Yeah. Yeah. Otherwise, if you make some big damage on your data, then the cost is huge. Okay. Yeah. Because you can imagine some of the data, in order to get the same data back, you may need to spend a lot of money, a lot of time, right? Yeah. So here I emphasize this part. I spent quite some time talk about this point because in the real world, it's very likely you have some situation, regarding data deletion part. All right. Yeah. All right. And these 4 operations are done by DBMS, Database Management System. Yeah. Yeah. Okay. Yeah. Yeah. And because SQL, we use SQL inside DBMS. Yeah. All right. Cool. Yeah, the last one. Yeah. Some database properties. One name, universe of discourse, UOD. Yeah. That is because when we design our database, we need to reflect the real world situation, right? But the part we want to describe just a part of the real world, right? We do not want to, reflect the whole real world, whole world. Yeah. So here we only focus on a small portion of the real world. So that small portion, we give a special name here, the universe of discourse. That's the little portion. We describe it in our business application. Yeah. Another name for it, we call it mini world. Yeah, because it's not a whole world. It's a small portion of the business world. Yeah, so we call it a mini world. Yeah. All right. So it represents some aspects of the real world. Yeah. For example, for our university business. Yeah. So we're interested in that portion, student, instructor, learning, that kind of business. Okay. Yeah. All right. So for that reason, we may need to ignore many unrelated things. Yeah. Something in the real world. Yeah. So you notice, so there are many objects in the real world, but in your database design, you may not need to represent them. Yeah. Because unrelated to your business. Okay. So although those things are visible there, but it's not necessary to represent everything you can see in the real world. Yeah. All right. Data representations directly reflect the states of the mini world. Here, the states. Yeah. We know the states can change at different time, right? Yeah, states keep changing. Yeah. But the states, when we talk about states, it corresponds to the data part. The business data, we know the data value. Data, each data piece has certain value, right? First name, last name, age, right? Grade, that kind of data. Yeah. So states corresponds to the data, yeah, but not structure of data. That's different concept. Structure of data. Okay. Yeah. Data is organized in certain structure. So that structure, that concept is different from the states. Yeah. That structure, usually we do not change the structure, although you can change. If you really feel your business rules require certain structure change, then you need to do it. But otherwise, after you organize your data in a special way, yeah, then you do not change your structure. Okay, yeah. If there is no good reason, you do not change the structure of your data. But the data values, the data stored, data stored in tables. Here, I haven't talked about another concept, the data organized, in tables. Okay, in tables. Yeah. Then when the states change, you change the data values stored in the tables. Yeah. So that's different. Yeah. All right. Coherent, another concept. Yeah. You need to consider in your database manipulations. Yeah. Coherent. Yeah. So what's that? Logically coherent with some inherent meaning. Yeah. We know data, they have some specific meaning in the business. And actually, the meaning, there are some logical relationship in the meaning. All right? Yeah. For example, here, let me just give you a simple example. Yeah. Yeah. Some employees, they may have dependents, right? They may have children. Some employees, they may have children. Okay? Yeah. So then, there is some coherent meaning behind it. Yeah. Employees' ages should be older than their children's ages, right? Yes. Things like that. So, some coherent meaning. Yeah. So a lot of things like that. Yeah. Because sometimes the data, there is something ridiculous could happen in your data. Yeah. Yeah. Sometimes the data may not make sense. That could happen. Yeah. That means when you run your business, you need to consider if your data makes sense or not. All right? If there is some ridiculous thing that could happen, you need to check that. Okay? You need to check that. Yeah. All right. So later we have a lot of discussion on that. Yeah. Yeah. Checking data. So if it matches our business requirements in the real world. Yeah. All right. So that coherent property. Yeah. Support the business in the right way. Yeah. Here we can only talk about in abstract way because we do not have specific business here. Yeah. Although I mentioned the university business. Yeah. The university business actually later, that is our first, for this, our textbook, we have two database examples, yeah, for our textbook. The first one is the university. So there is a university database. And the second one, company database. Yeah. So the whole textbook, we only use these two databases. And the second one is the, major one. Yeah. The first one, we use it, quickly. Then when we learn the SQL statements, we will change to second one. Yeah. All right. Yeah. All right. So support the business in the right way based on the business rules. Yeah. So you need to check those rules. All right. And how to check, what is the best way to check? We will discuss that part later. Okay. All right. Specific purpose. Yeah. So your business, you have specific purpose. Yeah. And so what's the meaning? Yeah. So here I provide valuable services for certain group. Yeah. All right. So that's the property part. Yeah. So then C.2, overview of SQL queries. Yeah. All right. Examples of SQL statements. Yeah. Here, I may like to give you a database example. Yeah. But the first database I give you in this class, I choose a very simple one. Yeah. It's not that university one. So the university database I will give you later. Actually, it's pretty complicated. Yeah. The first one I like to give you is a very simple example. Yeah. Create a MySQL database. Yeah. So the first thing we need to do, we need to create a database first, MySQL database. Okay. How to create? Yeah. So there are different ways to create. Yeah. So I will talk about that later. Yeah. Because we need to do that. So for our first example, I already uploaded in Canvas. So you can download it. It's called animaldb.sql. Yeah. So this one I used in my last year CS4010. So my CS4010 students, so you're familiar with this database. Yeah. All right. I just use this one as our first example in this class. Yeah. All right. And it contains a sequence of SQL statements. Yeah. So you will see, yeah, it's very easy. Actually, it has only one table. Yeah. After that table, there are several lines of data. Okay. Yeah. So, and this file contains the SQL statements we can run in PHP admin. So I mentioned last time, PHP admin. So after you install XAMPP, so you can run it. So I will, show you later. Yeah. Yeah. Here, I use this example to give you some ideas about the basic SQL statements. Yeah. All right. We can run the database script. How to run? Yeah. So that part I will show you. All right. So in my demo part, I will show you. Okay. Yeah. All right. Here, this is the definition of the first table. In this AnimalDB, we have one table. Yeah. It's called, the table name is called survey results. Create table if not exists. Yeah, look at the, so here you can guess the meaning, right? So first you create a table, but why you add this if not exists? All right, yeah. If not exists, you create it. If it exists, you do not create it. Yeah, because it's very common. If you do not include this part, then you already have the survey results, but you may not be aware of it. You run this again, then you will have an error. You will have an error because table already exists. Yeah. So if you put this part there, if not exists, then you won't have the error. If the table already exists, it does nothing. Okay. Yeah. Only when it does not exist, then this new table is created. Yeah. All right. So that's the table creation statement. Yeah. Then inside you can see, different things. Yeah. So we will explain later. Because this part, that's the data description, right? We describe our data fields. So that part, later we will talk about that. Okay, we will explain, line by line, piece by piece. Yeah. All right. Basic SQL operations. Yeah. All right. Retrieval. Yeah. Here, one simple example. Now, retrieval, insertion, update, deletion. Yeah. So with retrieval, select, star, represent all fields. Yeah. So in Unix, we use star, represent, everything. Yeah. Here, the similar way, all the fields. Yeah. You do not need to specify one by one. Yeah. Just all the fields. In this table, we have 3 fields. Field 1, ID, field 2, survey option, and field 3, votes. Okay, yeah. That table name. Yeah. Survey results, that's the table name. Okay, yeah. Insertion operation, the syntax is like this. Insert into your table name. Values, yeah. But here you can see we skip the field part, right? So here you can see in this step, no field. No fields listed here. Yeah. That means we use the table fields, all the fields, and following the same order as in our table definition. Yeah. So this is the table definition. Okay. This one, our table definition. Okay. Yeah. And in this insertion statement, we do not list any field here. Yeah. So we just use the field, all the fields in our table definition in the same order. You cannot change the order, in the same order. Yeah. But if you want to insert your data in different order for different number of fields, you need to write your field names one by one. Yeah. Okay. Yeah. Later we will go there. Yeah. Because at this time, it is our first view of this insertion statement. Later, we will discuss a lot of details for other variations. Yeah. Then update. Yeah. All right, so here, the syntax, update table name, set. Yeah. When you do updates, which part you set? Column 1 could be that ID, could be survey option. Yeah, that's the column. Yeah. Fields column, the same thing. All right. Yeah. So sometimes we use column, sometimes we use field. Yeah. Column 1 equals value 1, comma. Okay, separate by comma. Column 2 equals value 2, and so on. Okay. Where you specify condition. Yeah. I mean, so here, it's just the first view. Yeah. And deletion, delete from table name where condition. So that's structured, that's simple. Yeah. But with these examples, so you can see 4 examples for 4 types of operations. You can see, yeah, I capitalize some words, right? Yeah, some words capitalize. So let me explain that. Yeah. Yeah. These things that I do capitalization, they are SQL keywords. They are SQL keywords. Okay, so you cannot change. You have to use these keywords. You cannot change. Yeah. But these SQL keywords actually not case sensitive. Not case sensitive. That means if you use lowercase, that's fine. That's legal. Yeah. You can use lowercase for all the SQL keywords. Yeah. But uppercase, that's the convention. Okay. That's the convention in the community, in the SQL community. All right. Yeah. Yeah. Although, you know, if you use lowercase for the SQL keywords, that completely legal, but you do not follow the convention. All right. Yeah. So that means, you know, SQL programmers, so they follow, because that's the, you know, culture in the SQL community. Yeah. Yeah. And another reason people use uppercase, because you can separate SQL keywords from other non-keywords pieces. Yeah. For example, table name, it's not a keyword, right? Table name, values, you know, field names, those things are not keywords. So you can clearly separate SQL keywords from other non-keywords, data, and names, okay, for better readability. Another reason, okay, using uppercase way for better readability. All right, yeah, so that's, you know, convention thing, yeah. All right. There is another thing I'd like to explain here. Look at these symbols. Look at that, okay, yeah, that's quite special. So what's that? First, it's not a single quote. If you look at that symbol closely, it's not a single quote. Single quote, you will see usually, you know, something like that, okay? You know, yeah, that's the single quote. But this is this direction. From your keyboard, upper left corner, you look at that. Upper left corner, you can find the key on your keyboard. Yeah, yeah. So back tick, yeah, we call it, yeah, back tick, yeah. All right. So this symbol. So the question is why we use this symbol here. Yeah. So there is some reason. Yeah. Here, let me explain the reason. All right. Yeah. So the reason is actually quite, you know, not that simple. Yeah. All right. Here we know this place, this is a table name. All right. This is the table name. And these 3 field names. Right? Now, here the question. When you choose table names or field names, you base on your business, right? Yeah, typically you reflect your business aspects. Okay, Yeah. And do you have any restrictions when you select those names? Right? Yeah. Yeah. That question. Yeah. Think about if your table name or your field name happen to be the SQL keywords. What would happen? SQL keywords. Is that possible? Table name and field name, there is a possibility they could be some SQL keywords. That could happen. Yeah, because in SQL, there are a large number of keywords. Yeah. So I do not know how many. Yeah. You can imagine there are hundreds of keywords. Nobody you can memorize, most of them. Yeah. Yeah. Usually people just can memorize small number of SQL keywords. Yeah. Many keywords you may not realize they are SQL keywords. Yeah. But if you use by accident as a table name or a field name, you may get syntax error. Think about that. You may get a syntax error. Okay? Yeah. So now here, this backtick symbol is useful here. Yeah. All right. Although here in this example, if we remove those backtick symbols, we're fine. Yeah. We won't have any problem because we know survey results, ID, survey option, votes, they cannot be the SQL keywords. None of them is a SQL keyword. So we can safely remove all those backticks. All right. But think about in case there is a situation, you need to use a special name for your field, but that happens to be a keyword. But it's not good to change that. If you change that, you change the business meaning, so that's not good. You do not want to change that name. In that situation, to avoid syntax error, you use a pair of backtick symbols. Then it's like a escape symbol. So the SQL will not interpret as keywords. The SQL will treat it as some, just a string. Yeah, just, that particular string. Do not treat it as a keyword. Yeah, I've experienced before. Yeah, so that impressed me a lot. I've experienced. I did a project before. Yeah, it's a real world project. There is a field name. Field name, it's called a use. Just this name. Based on a business, this use field should be used. Okay? Yeah, that name is the use, but this use is a keyword. Okay? This use is a keyword. Yeah. So at that time first, I changed it slightly because definitely I cannot use keyword directly. So I changed slightly. Yeah. So I changed it to use, I add another E after it. All right. I add another E, to make it a non-keyword. Then, other people in the business, they won't be happy. When they see this use, they're not happy. All right. Yeah. So they like to use that use, yeah, but the solution now it's simple. All right, they just use this a pair of backtick symbols. Then it's fine. You can still use, but it won't be interpreted as a SQL keyword. All right, yeah. I spent a lot of time on this slide, yeah, because there are some important details. I hope you can learn. Then when you do it in the real world applications, you can avoid a lot of problems. All right. Next, C.3, database management system. All right. DBMS, let me describe this DBMS. It is a collection of programs managing databases. The DBMS, database management system, is a big application software, right? So inside this software application, there are many programs to, implement different features. So very complicated. So you can imagine it's a very complicated software application. All right, so it contains a collection of programs. All right. And it provides an interface between databases and end users. Okay, Here there are two types of interfaces. The first type, programming interface. For our programmers, it needs to provide us some way to access the databases. So we, as programmers, we need to use programming interface. All right. Another type, administration interface. So that's for business users. So business users, they need to access the databases, but they do not need to, access in the programming way. They do not write programs. So they do not use programming interface. So they use the administration interface. All right. Then the manage data, these four basic ways: create, read, create. Create a table, create database, create table, create many other things. Many other things, right? Create domain, create, so many different objects can be created. Read, that's corresponding to that retrieval operation. Read, update, and delete. These four operations usually, people put the initial together, so you can see in many technical documents, people refer to these four basic operations, CRUD, okay? C-R-U-D, CRUD operations. So you know the meaning. Next time when you see CRUD operations, it refers to these four different operations. All right. How about the insertion operation? Here you can see from the CRUD, we do not see insertion, right? Because the create, it's different from insertion. Read for retrieval, update, delete, create, but you do not see insertion, right? We know insertion is important. The answer is very simple. Insertion, it is included in this U part, update. Although we know insertion and update is different, right? Update, so you modify existing data. Insertion, you add a new data. But they have some common property. They change the data, right? They change the data in certain way. So then, sometimes people merge these two operations in one operation. Okay, it's quite common. For example, in Java, so I have some Java students, from last semester, CS4010, you can see when we do insertion operation and update operation, we use the same statement. We use not the same step. We use the same Java method. Okay, same Java method. Yeah, that way. Okay, yeah. So, all right. A general purpose software application. Yeah. So this DBMS, another property for it, it is a general purpose software. It's not a special purpose. It's a general purpose software. Yeah. What's the meaning of that general purpose software application? It does not rely on any business specifics and supports all business. Yeah. DBMS, MySQL, you can use it to run for all business, right? Yeah. It is not restricted to any specific types of business, right? Yeah. So that's the general purpose business. Yeah. So you can imagine when people develop MySQL DBMS, no specific business should be involved, right? Yeah, it's a general purpose. Okay. Yeah. So you deal with data for any type of business, it should work. Yeah. So the general purpose software application. Yeah. Usually running on database servers, especially for large databases. Usually. Yeah. Database servers. Yeah. Different from web servers. Right? Yeah. So in our first class, I mentioned that. Yeah. When we develop a web application, we need to run two different servers. First, a web server, Apache. Yeah, we use for this class Apache server, but that's not enough. We also need to run a database server because our database, all the operations we use for our databases should be running on database server. Okay, yeah. But here, I also say usually, right? You know the meaning usually, right? Most of the time, but not 100%, right? There is some special cases that do not belong to this usually, right? There could be some exceptions, right? Yeah. So here, I also mention exception case. In exception case, we do not use database servers. Yeah. The special case called embedded databases, powered by database engines, not the database servers, database engines. Still, you need some special thing to, execute SQL queries. Okay, yeah, but that's not database servers, database engines. What's the difference? Servers, engines, what's the difference? Servers, can be connected remotely, right? So you have IP address for the server, right? So each server should have its specific IP address. So you can connect through networking. Yeah. Engine is different. Engine does not have IP address. Okay. Yeah. The server can run remotely. Okay. Yeah. Can run remotely. The engine only run locally. Okay, yeah. You cannot access database engine remotely, right? All right, yeah. So the database engine embedded, think about when you have a small electronic device, you need to run some application in that small device, and you need to have some data in that small device. Yeah, in that situation, yeah, you may use a database engine. Okay, just inside that small device. Okay, it does not rely on network. Okay, it just runs locally. Right? Yeah, because that's a small amount of data that it's already enough for that little application for a small electronic device. Okay, yeah, all right. It's also possible, for example, some people, some business companies, so they develop some cell phone apps, okay, cell phone apps, okay, yeah, some special features, yeah. But if that apps do not rely on network, it does not need to connect to the, internet, yeah, because if it rely on internet, okay, if you do not have the internet service, then you cannot run that application, right? Yeah, think about that. In that situation, yeah, there is a possibility you use the embedded databases. Then you do not need the internet connection. No. So your databases, because you have all the data you need in that those databases, and you can do the queries through that embedded database engine. Okay, a small little database engine, yeah, support all the SQL queries, then it's good, yeah. So it's enough, yeah. So that special case, yeah, although not used much, yeah, but that different types of databases you need to know, okay? Yeah, you need to know. You may have a chance in your real world, you may have a chance you need to use embedded databases, yeah. All right, yeah. Properties, yeah. All right. Small enough, yeah. So embedded should not be too big, yeah, because usually, yeah, you run in an electronic device locally, yeah. Think about if your database is huge, that may not be appropriate, okay, yeah. All right. Second, contain basic functions. Now, simple, basic SQL operations, yeah. So you can do, yeah. All right. 3, work locally, yeah, without relying on networks. Yeah. All right. Yeah. Then the last property of DBM is very sophisticated with built-in efficient algorithms. Yes. Another important topic we will go there, efficient algorithms. Yeah. For the efficiency, we talk about for the retrieval operation. Because when we do a lot of retrieval operation, we want to make them very efficient. Okay, yeah. So then we will talk about the algorithms, how to make those operations very efficient. Yeah, yeah. The reason, especially efficiency here, especially important when we work on large number of data. Okay, think about the data amount. Our database could be in gigabytes. When you have that large databases, how to make the retrieval very efficient. All right, yeah. All right, yeah, we run out of time. Let me stop right here, and I will finish, yeah, I think probably only one slide left. Yeah, I will finish the last slide next time.